Alright gang, I'm going to try to go through a little bit of the PowerPoint that we talked about today. So let's see here. First one, we talked about when you're doing a piecewise graph. This one says whenever x is less than or equal to -2, that the y value is -3. So that would be down here, and we could actually put a dot there, and it would go this way. And this one says whenever x is greater than -2, it's 5. So I would go up to 5, and I would make sure I'm at -2 for the x-coordinate. So this would be an open circle, and it would go to the right. Okay. Okay, this one says whenever x is less than -1, that the y value is 1. So I'm going to go and put an open circle there, and whenever x is less than -1, that means the y value is always 1, so that's why that's just constant. Then it says whenever x is greater than or equal to -1, the y value is this, so that means I can plug in some points. So I'm going to plug in -1 into this, so that would be -1 minus 4, which would give me -5. So that means -1, -5 is a point. So we have -1, we go 1, 2, 3, 4, 5. I put a dot there. And then my slope is whatever is in front of the x, which is a 1. And, we don't usually write the 1, but it's 1 or 1 over 1. So from there, I can go up 1 and over 1, if you remember rise over run, and I can connect the dots, and then it would just extend. I could also just plot points. If I plugged in a 0, you could see that the y-intercept is -4. I'm going to do this one. So this one says that whenever x is less than -2, the y value is -3. So that would be an open circle, and that would go this way. And then it says whenever x is greater than or equal to -2, the y value is basically going to behave like a parabola. So I can start plugging in some points. So I plug in -2 in for the x. That would be -2 squared, which would be 4. 4 minus 2 is 2. So that means that -2, 2 is a valid point on the graph. I could plug in -1, so if I put a -1 in there, that would be -1 quantity squared minus 2. -1 squared is 1. 1 minus 2 is -1. Let's see. No. Yeah, -1. So that means that if I plug in a -1, it would be -1. Oops. And then if I plug in a 0, it would be -2. And if I plug in a 1, it would be -1. And if I plug in a 2, it would be 2. And you can see that this would be a graph that would look like this. It would be a parabola, but just from -2 and to the right. And this one's similar deal, so I don't think I'm going to do this one. Okay, classify each one of these as linear, quadratic, absolute value. So this one's quadratic, and of course this one's absolute value because it has an absolute value bars there. This one's linear. This one is exponential because it has a variable as an exponent. And then this one is square root. So we're going to do a similar deal. We're looking at the graphs this time, and we're going to determine what they are. So this one is a square root. So this is a square root. You can tell it kind of goes up. It's just been shifted. It's been shifted down. It normally goes like this. and it's just shifted down a few units. This one is exponential. So exponential. This one you can tell is an absolute value graph, so the V-shaped graphs are absolute value, at least the kind that we do, the linear absolute value. And okay, so now we want to get into solving the system. So we're going to use substitution for this. So we're going to take this quantity and we're going to plug it in for the y. So it's going to be x squared minus 5x plus 1, and that's going to be set equal to the 2x minus 9. And then we're going to solve for x. We're going to solve for x by moving everything to one side. So we're going to subtract 2x from each side. So that's going to give us x squared. We're going to have minus 7x. And then we're also going to add 10 to each side. Or I'm sorry, add 9 to each side. So we're going to add 9. So plus 9 plus 9. So that makes plus 10 equals 0. And then we're going to do a double bubble. So we're going to have a minus 5 and a minus 2 equals 0. We're going to set each of those equal to 0. So we have, and we're going to get x equals 5, and we're going to get x equals 2. And then what we do is we plug those back in to one of those equations, either one. So plug it back in. So we're going to have 5 and 2 as the x coordinates. And when you put the 5 in there, it's 2 times 5, which is 10. 10 minus 9, which is 1. Then I'm going to put a 2 in there, so it's going to be 2 times 2, which is 4. 4 minus 9, which is negative 5. So these are the two solutions. Okay, this one was causing some troubles today. So we're going to take this, and we're going to plug it in for the other equation for y. So it's going to be x squared plus 6x plus 1 equals x squared plus 7x minus 10. So now we're going to subtract x squared from each side. That's going to cancel out, and that's going to leave us with 6x plus 1 equals 7x minus 10. And then we want to subtract 6x. We're just trying to get the x by itself. So 1 equals 1x minus 10. And then finally we just want to add 10 to each side, so that will make 11. So x equals 11, and then we have to go and plug that in and figure out what the y coordinate is. So we have to just put it in right there and right there. So that's going to equal 11 squared plus 6 times 11 plus 1. So that's 121 plus 66 plus 1. That equals 188. So put the two together. That's 11, 188. State all the transformations. So when you're looking at this one, you can tell that the parent graph is g of x equals x squared. But it's had a few transformations, so it's had these two transformations. That plus 8 in the parentheses will move it to the left 8 units. So moved, let's just say right or left. So let's just say that this would be left 8 units, and let's say this would be down 1 unit. Keep it simple. Okay, what type of functions are these? So the one on the left is a parabola, so it's quadratic. The one on the right is linear because it looks like it's going up by 5. It's going up by the same amount, a constant amount. So this one's linear. Which one has a larger y-intercept? So the y-intercept is right here. It says 0, 3, and this y-intercept is right here. It is 0, 2. Looks like it hits the graph right there, actually. So 0, 2. And so this one, the one on the right, has a larger y-intercept. Do they have the same minimum value? No, this one has the lowest value of 1, it looks like, on the left here. And on the right, this one has a lowest value of 3. So no, they don't have the same. Do they have the same minimum value? No, they don't. So it should be, on the test, it's more of a statement. They have the same minimum value, and then you say true or false. I think that'll do it. Okay.